Hi, this series is going to document my efforts for a research project where I'm building a Hexapod robot that's going to be able to move autonomously and have a robot arm attachment to be able to pick up trash and other debris from public beaches. So you can think of like plastic water bottles is one of the main things I'm designing around. This episode is documenting about 3 weeks worth of work. And for this time period, the first goal was to just get the robot to be able to walk. And I'm going to walk through where I started and where I'm at now. So first, I was just looking at using a bunch of servos because they allow for very precise control for each of the legs. And to make a concept of a leg is actually very simple. You have one servo that controls the hip, so you're going to be rotating across the hip joint, and then the other servo is going to be controlling the knee, so that's just going to bring your leg up. So you can imagine the way you can program walking is you bring the leg up, you turn the hip, you bring the leg down, you turn the hip back, and that friction between the leg and the ground is going to cause a forward movement by Newton's third law. So once I had that, I spent some time testing it, made sure the concept worked, and then I worked on designing the plate. To design this plate, I really didn't do anything too fancy. I just made sure I had a spot for each of my motors, and I wasn't fully thinking about where the electronics were going yet. I just knew I had enough space for an Arduino and a motor controller. So the next step was assembling it all together. So now we have 6 legs. Each leg has 2 motors, so 12 motors in total. I guess it technically walks, but we have to make some legs. Now I have the full robot assembled with 6 legs. It was able to walk, as you can see. Because I assembled each leg probably slightly differently, I had to find the specific range of angles that the servo motors had to rotate to get the movement I wanted. So I spent a lot of time just doing calibrations, but once they're all set up, I could also easily extrapolate this to make my robot turn right, turn left, and also go backwards. So yeah, I'm pretty happy with the progress so far. I achieved the goal of getting the robot to walk. The next steps are, you can obviously consider the fact that since this leg only has 2 degrees of freedom, it is going to be very limited because every real hexapod out there uses 3 degrees of freedom for each leg to navigate uneven terrain. So that's something I'll be thinking about probably in the farther future. More immediately, I'm going to start working on making the robot arm such that it's going to have enough workspace to reach the plastic bottle, say, in front of it. And also, we're going to be doing a lot of work integrating a Raspberry Pi to start making this robot autonomous. I'm thinking of using ROS and Gazebo to simulate the robot in action, and then hopefully figuring out how to use ROS packages to create some nodes that do some magic stuff that let it run. So that's the plan, and I'll hopefully see you next time on Hexapod Adventures.